All right, so the topic is geologic time, which we need to find the evidence for this geologic time as well as have an understanding of how we measure that amount of time, okay? So going forward here. So the Earth is always changing. All right, before we get into what this says here, let's look at this mountain. All right, you think this mountain has always looked this way? No. Probably not, right? Yeah, especially with this funny little like boulder nubbin thing on the top. First of all, this mountain had to rise somehow, or it needed to be differentiated from the rest of the Earth's surface. So it is sticking up here. More than likely, this whole situation is due to erosion, right? Which is a process that you understand well, or at least you should. The continents are moving. Life is changing and going extinct. This is really important, okay? This last one, life changing and going extinct, is really important. And you'll see why when we get to how we name the different eras of the Earth's history, okay? When I say that life is changing and going extinct, what comes to mind?
Dinosaurs.
Yeah, people always go to dinosaurs because, you know, big lizards are cool, I guess. Even though they weren't really lizards, but that's a discussion for another day. They weren't reptiles.
They were related to chickens.
The dinosaurs were birds, and birds are dinosaurs.
So chickens are living dinosaurs.
Chickens and every other bird are dinosaurs, yes.
Oh.
I wish that wouldn't happen, but I can't change it. Okay, so all of these changes are recorded in rock layers. And so when we talk about rock layers, the word that we use in science is strata. Strata. Strata in the rocks are distinct layers of different color, texture, and composition. They also have different fossils in time. These layers are almost always organized by age, with the oldest rocks at the bottom and the younger rocks up at the top. Okay? So when we talk about these strata, you can see very clearly that there are layers of different color and texture in this rock. We have kind of a lighter color here near the bottom. It gets darker, very dark red. There's some lighter layers here. A very light layer here, a very rust color red here. And we get all of these different layers. And the reason why this happens, we will discuss in just a minute, but almost always the layers are older at the bottom and younger at the top. All right? Younger at the bottom, older at the top. And we'll talk about what is important about that in just a minute. Okay, moving on. So remember how rocks form, specifically sedimentary rocks. I'm going to come back to this slide in just a minute, but let's do some drawing here, because I know that you all really enjoy my drawings. They're so beautiful. So if we go, let's do this here. We're going to use black as the... So we have a solid surface here. Okay? And this solid surface is sloped, and you'll see why I did that in just a second. And this happens to have a lake. Look at those beautiful waves. Beautiful, okay? We have this lake here. Well, this lake has a river that flows into it through a waterfall. Okay? Gorgeous, I know. Well, this waterfall is coming from an area that has all these little red dust particles. And those red dust particles come down into the lake through the waterfall, right? And they disperse into the lake. Well, all of these particles settle down at the bottom of our lake in a layer, just like this. Beautiful red layer. I know, so wonderful. Well, they've all fallen out there. Well, let's say that over the next few years, there's not a lot of erosion going on, so we don't get many more of these red particles. But over this time, maybe there's a big explosion of shrimp that live in this lake. Got some shrimps floating around doing their thing. Shrimp is delicious, by the way. I love shrimp. If you don't like shrimp, that's okay. Not everyone can be right about everything. Okay? Well, one day all of these shrimp happen to die because, I don't know, pollution, sure. I don't know. Okay? And all these shrimp die and fall down to the bottom of the lake, and they make a layer of shrimps. Got a shrimp layer here. Okay, so they're all dead. They all fall down to the bottom. I know, the bell's annoying. They all fall down to the bottom of the lake, and they make a layer there. Okay. So once again, we get maybe some heavy rains, and these rains come in, and it floods the whole area, and so a whole bunch of new sediments come down. And these sediments, once again, are this red color. And so we end up with another layer. Oh, I'm not meaning to cover the green layer. We get another layer of red sediments here. And then maybe there's a big volcano that erupts, and it sends ash up into the air, and that ash all falls into the lake.
Well, this lake ain't too comfy.
And it settles down in the bottom of our lake. So do you see what we've made here?
Yes, we made it.
We've made sedimentary rocks, right?
Yes, sir.
So I'm going to move this out of the way here, and we're going to look at this. So sediments, meaning little pieces of rock and organic material like those shrimps, right? They pile on top of each other, and they make these different layers. This happens at the bottom of lakes and oceans. Sedimentary rocks have to form in water.
Can they form in volcanoes?
Volcanoes form igneous rock.
Those are going to be made by intense heat.
Yes, those are the ones that are melted and then redistributed. So the sediments are then glued together by the pressure and chemical bonds. So at the bottom of our lake, you have this pressure that glues all these different layers of stuff together. So we end up with a sedimentary rock with multiple different layers, and we can see these layers here. Maybe this is this layer here, this thick layer right there, is from a flood sediment. Maybe this white layer is actually the shells of little crustaceans, little clams and oysters and so forth that lived in a lake, and they all died around the same time. They were all deposited at the bottom and made a layer that's kind of white in color, right? So we have these different layers. So if we were looking at this layer up here, we're looking at this layer up here, and we were comparing it to this layer here. So this is layer A, and this is layer B. Which of these two is older? Which of these two is older? A up here or B down here?
B.
B.
Yeah, you can tell.
B is older. Why?
Because of the color change, it's also on the bottom and bottom.
It's on the bottom. Okay, the color doesn't have to do with age. It has to do with where it is in the layer. Because remember, when we look at our beautiful Mr. Croshaw patented illustration, we have a layer that formed here, and then our shrimp layer on top of that, and then another red layer, and then the volcano layer. So we have all these different layers, but they form one on top of the other, okay, stacking on top. Let me get this out of the way again for the time being. All right, so that's sedimentary rocks. We also can end up with igneous rock layers, okay? Igneous rock layers, and I'm going to come back to this slide in just a second, so don't everybody freak out. Well, that same volcano that put all this ash into the lake erupts, but instead of sending ash up, it's lava, and this lava flows into our lake. Blue's not a good color. Let's go with yellow. And this yellow rock is igneous, okay? It's not made out of sediments. It's lava that has flowed? That has flowed, there we go. That has flowed into our lake and cooled into a rock. So we can see here, this is magma, yeah? Got this, oh, this is actually lava. We'll talk about the difference later. This is lava here. And you can see these people that are apparently deciding to, be a little bit risky with their lives. And you can see this flow of lava that is cooled into a layer of black rock. Proximity to a volcano, sometimes you have layers that are almost exclusively igneous, which means they were made by volcanoes. Or sometimes here in Utah, for instance, in northern Utah, we only have sedimentary rocks. Northern Utah used to be underneath a vast inland ocean. So we have mostly sedimentary rocks from that ocean. It's almost all sedimentary. If you go to southern Utah, there's a whole bunch of dormant volcanoes in southern Utah, so you can find igneous rock down there. Okay? So we have sedimentary layers, and sometimes we get an igneous layer on top of the sedimentary ones. It just kind of depends. But most of the time when we talk about rock strata or rock layers, we're talking about sedimentary layers. All right? Okay, moving on. So the geologic column is a model of all of the layers of the Earth's history put together. So scientists have kind of put this together over the last 200 years of studying rocks to understand a little bit of the whole history of the Earth, the geologic column. We have an image here that is not the geologic column, but this kind of gives you an idea here. So once again, we have these different layers, and they're all labeled. 1A, 1B. The 2s are over here. 3, 4, 5, and 6. Okay. So scientists have studied the layers of the Earth for 200 years to learn the relative ages of all the rocks over the planet. It's difficult because each area of Earth has a different part of the record. No one place has a complete history. Geologists have assembled the facts into a single model called the geologic column. So the geologic column is a comprehensive model of the entirety of the history of the Earth over time. Okay, that is the geologic column. Does anyone have a guess as to what this image represents, where on Earth this would be?
what southern Utah looks like.
It does look like southern Utah. You're really close. Huh? Arches is super close. This is the Grand Canyon.
Bruh.
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 Bruh. Okay? The Grand Canyon has 6 distinct layers, all of which are broken up into sublayers. You can see 1, 2, 3, 4, 5, and 6. This represents several 100 million years of Earth's history.
Oh, man.
What's going on with layer 2 here? Anyone want to take a guess as to what's going on with layer 2?
It looks like it's growing.
It looks like it's sideways, right?
Yeah.
So we have these layers that are all nice and horizontal, right? They just run side to side. 4A is kind of interesting because it's like filled in riverbeds. But you have all these layers that are nice and horizontal. They just run straight across. 2 and 1 are different. So remember when we talked about the mantle of the Earth being plastic?
Yeah.
That the rock can be bent in the mantle. Layers 1 and 2 are representative of things that used to be in the mantle, and the rock has been bent. The rock has been bent and misshapen. So these layers were formed horizontal originally, but because of the movement of the tectonic plates and so forth, they have shifted and been bent and deformed. All right? So that's what happens there. And then all these layers formed on top of each other in some ocean. And then when that ocean was either displaced by tectonic plates or whatever, this ended up above ground, and then the Colorado River came and eroded away the canyon so we can see the different layers. Okay? All right. So remember that the Earth is 4.5 billion years old.
Yeah.
And when we talk about the history of the Earth, we need to have an understanding that things have changed a lot, okay? And that some of the biggest changes are related to development and evolution of life. We are able to look at different layers of the Earth's crust and understand a little bit of what's going on there based on the fossils that we find in it. Okay? So this brings up another topic that I need to clarify with you all. And that topic is relative age versus absolute age. Yes? Yes. Okay? So when we talk about finding out the age of the Earth, we talk about relative dating. Make this bigger here. Versus absolute dating. You can also say relative dating, or sorry, relative age and absolute age. So when we talk about relative dating, I'm not talking about going on a date with your cousin. Gross. there's some pretty funny stories about like some people that I know that they were dating and then they were thinking about, you know, getting married or whatever. And then they found out that they were second cousins. It was like, yeah, maybe not. Although I think it is funny that like everyone in this room, I guarantee is related within 15 generations. So I am no farther away from any of you than 15th cousins.
So when we're technically married, we're related.
Well, we're related to every living thing on the planet. So, like, I'm related to those geckos over there, and so are you. We just share an ancestor several 100 million years ago. How are we related to geckos? We are both vertebrates, and we have an ancestor that was a vertebrate. That there was, so, Silas, there was an animal that had 2 children, or more than that, and one of those children went on to be the ancestor of the geckos, and one of those children went on to be the ancestors of us. All living things on Earth are related. Why is that weird? Just you never thought about it. That's why you think it's weird. But yeah, so like you are all related pretty closely together. Like for instance, my wife and I are 11th cousins, which is pretty common. Most of the time, people that you meet are either your 10th, 11th, or 12th cousins. Like I guarantee you, I'm probably within 12th cousins with all of you. Pretty crazy. Pretty crazy. Yeah, Jacob.
What about me? Because I'm like from across the United States.
Oh yeah, no, still for sure. Because we're talking about like 15 generations goes back to like the mid 1100s. So all of us have European ancestry here. All of us. And so we're all related within 15 generations, I promise. So pretty crazy. Anyway, so I'm not talking about dating your cousin with relative aging. Relative dating. Relative dating is determining the age of rocks as compared to other rocks. Okay? Absolute dating gives us determining the age of rocks that produces a specific number. So, for instance, when we're talking about relative age, I am older than you, right? But so is my dad, right? And my dad is 67 years old. Okay? He is older than you, and so am I. And so is, you know, the Tyrannosaurus Rex fossil. But knowing relative age doesn't give you numbers. It just says this thing is older than that thing. That's all, right? But when we want a specific or absolute age, I am 30 years old. You all are 14 or 15 years old. That is a number. That tells us the exact amount of time that has passed. Okay? So relative dating versus absolute dating. Do we see the difference there? Okay. So when we're looking at, for instance, when we're looking at the age of the geologic column, we know that 4b is older than 6a. Right? That's a relative dating method. Just by looking at the strata, and saying this one's below that one, therefore it means that it's older. But could you tell me just by looking at the position of the strata what the age of 4B is? No, you couldn't. You couldn't. You would have to say, oh, we need a different way to determine the age, right? We need to find a birth certificate, right? Or we need to find some way that we can determine the age of things. And we will talk about that next time when we discuss radioisotope dating, okay? And that's how we get specific numbers for things. Okay. Questions on any of this? All right. So we don't really, so we do use millions of years to measure the age of the Earth, but it's a little bit more complex than that. Okay? We use terms that are a little bit strange to most of us. I'm sure that most of you recognize this one right here. Okay. Okay. So when we look at this, by the way, I'm going to expect that you have this memorized for the exam. I'm just kidding.
I'll just go to write this down.
Everyone's like, oh no. Yeah, no, you don't need to have this memorized, but I do expect you to understand at least a little bit of what it means, okay? So we'll come back to this later in a little bit. We need to understand the basic underlying principles though, okay? We have eons, which I think is just kind of a funny word. Eon. Eon. It does sound like yawn, just saying it really slowly. Eon. All right. The eon is the longest division of time when we're talking about the Earth's history, followed by an era, or an era, followed by a period, which is a subdivision of era, and an epoch, which is the most specific of this way of classification. So eon, era, period, and epoch. EEPE. Now, that is helpful at all? Eon, era, period, epoch. I like to think of epochs as days, periods as weeks, eras as months, and eons as years. Eon, era, period, epoch. And we got our good old pal here, Stegosaurus. And the dinosaurs are gone.
You gotta watch that whole video.
We have this dinosaur here, the Stegosaurus, right? Stegosaurus, they were super interesting. The more that we learn about them, it's very likely that they could change the colors of their skin on the outside of their plates, which is pretty cool. Might have been able to flash them red. So pretty cool. Okay, so that's where we're going to end it today. Eons, eras, periods, and epochs. We're going to talk about each of them specifically next time. We'll talk about the Hadean, the Precambrian eon, the Hadean era, the Archean era, Proterozoic era. Okay, we'll talk about all these different portions of Earth's history, but we're going to leave it at this today, right? So we'll stop it there.